apparently we're just starting off with drink, everybody. Apparently that's happening. All right, well.
Oh, look at that intro. Oh, look how nice
I
that
forget
is. It's
because we're using
clean.
YouTube now. There's like a slight delay between what we're doing live and then what everybody else sees out
Yeah.
there. So we'll try to remember that and everything. Before we actually start the main recording, we're recording, but the main podcast topic, we are actually going to do a little Percy recap for everybody. So before we start that, let's just say hi. We got Jack out there so far, so that's
Hey, Jack.
cool. Oh, okay. My tea thing almost went into my glass.
Okay.
I would have had a fully submerged tea bag.
Well, okay. All right.
Cool. So, Katie's out there.
Hey, Katie.
Yes, I did help Mom get set up. She said it works. So I guess we'll see if it works.
Why can't I see their chats? Oh no. Oh, there they go. That's weird.
Oh, okay.
Now we're back.
Okay. Oh, Jack can get behind my drink. What? Because it's tea. It's not just tea, but we'll find that out in a little bit.
Mm-hmm.
All right. So.
Hey, Adam.
Percy.
Someone's excited to get going. All right, let's talk Percy, because hey Adam, because exciting stuff happened. We actually have video of a rover landing on Mars, and it's the most amazing thing ever. This isn't, of course, new news since it's been like a week or whatever since the video came out, but we just thought it'd be fun to play it and kind of talk about it while it's going on. So let's have that. Jettison the entry balance masses in preparation for parachute deploy and to roll over to give a better look at the ground.
Indicate chute deployed.
Okay. Yep. Oh.
Navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 140 meters per second at an altitude of about 12 kilometers from the surface.
It's like JPO's slogan, which is I love that slogan so much.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
And then it was so cool too, as it was rocking with a parachute, it kind of like went over to see the giant cliffs of Jezero Crater as well. You got like an overview of the landscape. That was just neat. Yep, there we go.
6.6 kilometers above the surface.
Mm-hmm.
Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OBS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Beautiful. Yeah. Checks out.
Velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars.
That might be okay.
Hey, there we go. Now you guys can maybe hear us because I've been talking.
Yeah, we've all been talking.
They've been able to hear Brandon, but I just realized you guys couldn't hear Mike and I.
Oh, that's weird. Because I'm like 2 minutes behind on the YouTube video, so I don't know where you guys are at and where I'm at's different.
We're all okay. So we're getting closer. So the rocket, the hydrazine rocket thrusters on the sky crane are gonna start firing, and we're gonna see the evidence of that. Yeah, it burns clear, so you don't see any fire coming out of it. Oh, but look at that happening. Okay, so we have the top camera is looking back at the sky crane, and the bottom one is obviously looking at the rover descending on those cables. That twisty one, that's the communications cable that's transmitting the signal, and then shortly those cables will break.
It goes
and,
from the sky crane to the rover.
yeah, and cables are broken.
There
Goodbye.
you go.
Bye,
There
sky
goes
crane.
sky crane.
Oh,
Oh my gosh, and that's exactly what we did.
There were tears.
Oh, so great.
Amazing video.
it's just incredible how many thousands of things have to automatically go right. Everything from obviously getting heat shield jettisoned to actually lowering the wheel so it doesn't land on its chassis. It's just awesome.
I know.
Chassis. That's what I wanted to say.
Chassis.
Yeah, and cutting the cables. You got to cut the cables.
Gotta cut the
that.
cables,
It's
or else the sky crane's gonna take Percy with it.
Which, to be fair, would actually look kind of cool with those cameras on board that all of a sudden is just like, whoa! But disastrous for the mission, obviously.
right. We
But
would
it
have
makes
had a
some
very
incredible
different.
gifts though for the internet.
Yeah. So here are some images that had come down to more recently. I didn't grab the ones that I guess came out today. So we have this top one is the first panoramic super
Incredible high resolution.
it was you looked at it was like 30,000 plus pixels.
Yeah, it was like 38,000 pixels by like, I don't know, 12,000 pixels.
Yeah.
It's incredibly huge. So you can really zoom in
Zoom the
and
fuck in.
you can pick, just some part of the Martian landscape doesn't really look like it has much and really zoom in quite far.
Mm-hmm.
And you can see a lot of rocks on the surface and all of that. So it's insane.
It's so gorgeous. And then I included a couple pictures of just the rover itself, kind of some elements on there. There's like calibration targets, and that on the picture that is on the right, and it has a little
In the middle, yeah.
it has a little color
Wheel.
color wheel
Yeah.
with that little shadow stick thing. I don't know.
Sundial.
Sundial.
I can't see it on my little phone, but did you see on Perseverance on the top? There's like a family tree of the rovers.
Yeah,
Did you see that?
I did.
That was
see
that was good.
Yeah, there's a just
That was
like
nice
it's
to
like
see.
it's like that evolution sticker with like
Yeah.
to man, and it's like the evolution of the rovers on Mars. Ugh,
You
love
may
it so
look at the
much.
bottom panorama though. Look how rocky it is,
Ugh.
and the technology for Perseverance is new, where they can land in a very rocky place like this. They kind of tried to ignore that before because I mean, if the rover lands on a big old rock, then you're pretty much screwed.
Yeah.
But now they can with the software they're able to as the rover comes down, it can actually pick where it wants to land and not actually land on top of a rock.
Nice.
Right. And even like Spirit and Opportunity could never probably drive in an area like this. So many rocks. Percy's so big, number one, and its wheels are far more advanced now than Curiosity. It can, go on rocks, not get punctured or get damaged. So we can do more things now than we could have even 8 years ago. Love it.
It's exciting.
Technology. All right, back to us. Hey, here we are.
Hey y'all, how you doing?
We're here. We're here. All right. Let's get into the meat of the show, which means Brandon, you're up.
Let's do this.
Oh, I like you're wearing your Mars shirt.
Oh, well, I found it because it was in Phoenix.
Oh, okay. Well, there you go.
New location. All right. Want to give me the old countdown?
Oh, yeah.
Davison?
All right, let's get this podcast roll on the show in 5, 4.
Hey everyone, welcome to yet another episode of Cosmos with Cosmos. I'm Brandon,
I'm Liz.
I'm Mike.
and today we answer a question that has been asked to me dozens of times while working in the planetarium.
But
They
it
would
has
always
never
ask.
been asked to me
Never.
or Liz.
Never got
Really?
this question. Nope, never
Never.
got this question.
So crazy. I got it all the time. And the question was, Jupiter's a gas giant. Gas is flammable. Can you light Jupiter on fire? We'll answer that very quickly.
How old was the first time that you were asked that? How old was the person who asked you that?
Probably around 12.
Oh,
I
I was
wanna
going to
say.
say 7.
Yeah, that's what I was going to say.
Well, I mean, so many people don't, what we think is basic space knowledge turns out is not. Like, how many adults did we have that didn't know the sun was in the center of the solar system, for example?
yeah,
It happened more than you think. And so at
cool.
least these guys are, connecting the dots in the head, thinking gas, flames, gas giant. Can we light it on fire? Yeah. No. But
I mean, I love the imagery. I love thinking about that.
Oh, I know, right?
What, just Jupiter would look like on fire.
Yeah.
Yeah.
Sorry, I got lost in the image of a quick of Jupiter. Well, yeah, so we'll be diving into that, and then we'll talk about what it actually takes to possibly light a gas giant on fire. Big bada boom. But before we get into that fun stuff, we, of course, want to go over what we're drinking today. So, Mike, what you got drinking?
I have 2 drinks as usual. Well, really, I have 3, but one doesn't have alcohol in it. This is the Great Red Spot, which is just cranberry juice and cinnamon whiskey. That's drink number 1. Drink number 2 basically is just a blood orange Moscow Mule with cranberry mango as a mixer.
Nice.
And I am calling it Earth's Great Protector.
Oh, fun. I love that by now we can kind of find the trends of what we like to drink, whether that is mules or cranberries or like White Russians. So Liz, what do you have then?
I am drinking a Great Ball of Fire.
Yeah.
And it is cinnamon tea and cinnamon whiskey.
A lot of cinnamon.
A lot of cinnamon. It's
A lot
good.
of cinnamon.
It's good stuff.
Does it taste like Christmas?
It tastes
the
like
cinnamon.
warmth, really, is what it is. Just tastes like being snuggled in a blanket on a cold day
Excellent.
Nice description.
and lighting gas giants on fire.
So we will not be having this in July.
No, probably not. Brandon, what do you got?
I am drinking Drops of Jupiter, which is tequila, orange juice, a splash of grenadine, and of course my favorite, blueberries. That's the Jupiter part, the Drops of Jupiter. Drop into blueberries.
That's adorable. I love it.
Yeah.
Jack is having a raspberry truffle with dark chocolate latte with an extra large marshmallow.
He always just
homemade.
destroys us.
Yeah, he does. He really is the king of. He's the king of drinks.
He probably grew the cocoa beans as well and cultivated them and homemade them and brewed them himself. And they're amazing, I bet. So anyway, we have a couple of social medias. Feel free to follow us on the Twitter at Drinking Cosmos, the Instagram for all the pretty pictures at Cosmos with Cosmos. Follow us, rate us on iTunes, Spotify. If we still have Google, I'm not sure. But wherever you get podcasts, we're probably there. If not, there's always iTunes.
Yep, you can also go to our website, cosmoswithcosmos.com, and we have a podcast player built in there that has our 10 most recent episodes, so you can always go there to listen
Beautiful.
as well.
And of course, don't forget to join us for the Hangover edition. For those of you on podcast land, this is where we hang out on YouTube after the podcast and we go down the rabbit hole of whatever our tipsy minds think of. It's a lot of fun.
Yeah, we don't even have an agenda for that.
Nope. No
Nope.
agenda, now outline.
And you can find those recordings on the YouTubes.
Phew. And finally, before we begin our show, we have a couple of drinking rules. So play along at home, Jack. This is for you too. These rules include if there's any kind of puppy barking, any Amazon coming in today, Mike, for the dogs?
No, I got my Amazon yesterday.
Oh, hey.
And then I get my Amazon on Tuesday.
Oh, okay.
So-
Good timing then.
And we're actually doubling the possibilities because I have 2 dogs here. Scout and Baxter, which I love.
Oh, it's exciting.
Yeah, but what's
Well,
your sister's dog's name?
Pippin!
Pippin.
And its sister is Mary. It's Pippin and Mary.
Oh my god, I love it so much.
But
It's,
they are unfortunately
sorry,
not there.
The full name is Mariatic Brandy Burke.
Brandy bark.
That is awesome.
Oh
It's
my God.
it's so Pippin is so long. It reminds me of Falcor from Neverending Story.
Oh my God.
It's
Falcor's my
great.
favorite. Oh, jeez.
They're corgis, right?
The corgis, yes,
Yeah,
they're just
corgis.
very long corgi boys.
Just-
So that's rule number 1. We take a drink. Rule number 2, if any of us make a Star Wars reference, we take a drink, which happens. And rule number 3, if any of us make a Lord of the Rings reference, which would be difficult because we just talked about Pippin. But that was before we announced the rules.
Yeah, it was pre-rules, so it doesn't count.
All right, so with that, I guess we should talk about, can we light a gas giant on
Yeah,
the fire?
let's get into
Yeah.
it. First of all, I think we need to maybe do a little overview of the gas giants on, what are they?
Why are they?
Just to
How are
backtrack
they?
for a second, of all the episodes, we should have had your dad on this episode.
So we can come in hot?
He can come in hot. He can tell us about fires.
Yeah,
was
because
thinking-
he's a retired fireman.
Oh,
Yeah.
I was
Captain.
thinking, is he gassy? That's what my mind went.
I mean, maybe. I don't know.
And that's what
no,
the dog's looking for.
That's Leia,
Yeah, Leia's,
our dog Leia. Oh my God,
Whew.
man, it's destructive. It is
A
so
gas-
destructive.
A gas dwarf.
Gas giant dog.
Oh, she's 98% gas.
Yeah. Oh, yeah.
Yeah, and it's
And 2% force.
So what is a gas giant?
Well, a gas giant is a planet, a big planet that is made primarily of gases. Of course, we
Weird.
have...
so
we-
very descriptive name.
Right? I mean, look, okay, the thing that I love about, astronomers is that they pretty much name things, they call it like they see it, essentially. For example, hey, there's a bunch of mass we can't see, so let's call it, or matter we can't see, let's
we don't
call
know what it
it
is.
dark matter.
Yeah. And that space rock is made of a lot of rocks. Let's call it an rocky asteroid.
And
Or
hey,
Big
here's,
Bang,
here's
black hole.
a big gravitational thing we can't see. It's like a black hole. That's a good name.
So a giant ball of gas traveling around the solar system sounds like a gas giant. I mean,
giant.
which I found out today in prep for this episode that a gas giant wasn't named by scientists. It was named by a science fiction writer in the 50s. And this writer went on to write novelizations of Star Trek.
What?
So that's kind of cool. It's just a recent thing where they called it a gas giant.
So what? Like William Herschel, when he discovered Uranus, never called Uranus.
Didn't they
No,
call
you
it?
just called it Uranus, I guess.
Well, I guess he would have called it an ice giant. Heyo.
Well,
No, he just called it George first.
yeah, he called
yeah,
it George.
was George.
And then it was Herschel's planet for a while, which is kind of weird. And then we got
then,
Uranus.
and then we had to stick with the whole Roman mythology naming system, and so Uranus.
Naming in astronomy is just screwed up. It's so
Yeah.
screwed up on
Yeah.
so
Yeah.
many levels. What
Actually, you know what? Uranus is actually not Roman. I don't believe. I believe
No,
Uranus
it's
is
the
actually
one-
Greek.
Yeah, it's the one planet not Roman.
Yeah, it's the one planet that is still Greek, and the Greek pronunciation would be Uranus.
Oh,
Wait, and that was the Titan that was eating all of its children that Jupiter eventually destroyed, right? Or was that Kronos? I don't remember.
No, Kronos is the one that Kronos was Zeus's father, and Zeus ended up killing
Oh,
Kronos.
okay,
So,
that was Kronos.
yeah.
I need to brush up on my Roman and Greek mythology. Sorry, guys.
Jackass, was it Larry Niven? Is that the
No, it does. I don't think it was. We'll have to Google it right after this. It's on the Wikipedia page of Gas Giant.
There you go. Your source for everything, Wikipedia.
Yes.
So basically, as the solar system was forming, there's a big cloud of gas and dust that's spinning around, and you had all these dusty particles coming together and getting bigger and forming what we know as the terrestrial planets. And those gases being further out, they came together and
And this is important for later on. What was the most common gases in these kind of disks that as the planets were forming?
the most common
Yeah.
gas in the universe, hydrogen.
Exactly. That comes into handy later on in this episode.
So we get the gas giants, Jupiter, Saturn, Uranus, and Neptune, made of gases.
yeah, but what's in the middle?
They almost likely have solid cores.
Hooray! If you
Yay.
go back and listen to our episode of I think it was deep impacts, big hits, something like that. We talked a bit about how Jupiter's form, like Jupiter's core, rather likely formed when like a Mars Earth-sized object slammed into it and kind of messed with the core a little bit. So we do know there is some kind of solid core within Jupiter.
Mm-hmm. Mm-hmm. And that core is about the size of the Earth, right?
Yeah, it's a big thing because you have to have a lot of gravity, a lot of mass in there to hold on to all the gases around you.
Mm-hmm.
So Earth's core is obviously not the size of the Earth, so we can't hold on to all this atmosphere that Jupiter has, for example.
Yeah,
and there's other reasons as well.
Yeah, I was gonna say, and because like gas giants the terrestrial planets are closer to the sun, so that basically this solar wind and the heat from the sun doesn't allow those gases to exist, stick around that close to the sun, but they can further out.
Mm-hmm.
So if you have a gas giant, can you fly through it? Ignore the core, the solid core.
No, we've talked about this. You can't. It's not a cloud, people. It's not a cloud of gases that you. Well, I guess it's a cloud in a sense, but it has cloud layers.
Has cloud-like tendencies.
But it gets very dense and very hot the further down you go into the atmosphere. So, like if you were to jump into Jupiter, don't recommend it. You would float down a bit until things got so hot and dense you would get stuck and crushed and just
now is it so dense? Is it so dense you can swim your way out of it?
No, because
you'd be crushed and disintegrated and burnt.
Yeah,
you'd die pretty fast.
It wouldn't be good.
It would not be fun, no.
No.
But you'd see some really cool stuff before the sun's blocked out.
That is true.
That is true. And I mean, Jupiter has it has like a metallic hydrogen layer, and that's what causes its magnetic field. Is that metallic hydrogen layer?
Yeah, it's above the core.
Yeah.
So you go down, and it gets thicker and thicker, and the density increases, and then you get like liquid hydrogen and helium. Even though it's really hot, the densities are such that you can actually have liquid hydrogen. You can have hydrogen and helium in liquid state. Here on Earth, it has to be very cold for that to happen, but because the densities on Jupiter can be very hot. And then you get this really cool state of liquid, metallic hydrogen, which is spinning because Jupiter spins. Like one day on Jupiter is like
it's so fast.
10 hours long.
I think it's like 16 hours, I want to say.
Oh, it's less than that. 16
Saturn?
hours is
12.
Uranus and Neptune.
Must be 12 hours then. It's
it's like 12 hours. And then Saturn's 10. And so it's spinning so fast. And anytime it sets up this electric current, which then creates magnetic field. And very strong magnetic field.
Like, I want to see what metallic hydrogen looks like.
I always think mercury.
Yeah,
it has this mercury look to it.
That like just this
like a little quicksilver look to it.
Yeah.
Huh.
But that's not the topic of this episode.
No. So Jupiter itself, the vast majority of it is hydrogen. Mm-hmm. It's like 86.4% exactly of it is hydrogen.
It's very specific, Brandon.
Right. It's like we have it in the notes or something.
Weird.
Okay, so hydrogen, if it can explode here on Earth and cause fires. So why can't you do that on that gas giant?
Well,
involves. Yeah, go ahead.
The problem is, so basically, to set shit on fire, you need three things. You need a flammable substance, you need an oxidizer, so like oxygen or air, and then you need a source of ignition, so like your spark or some like high heat.
So let's really quick kind of break those things down, because oxidizer and source of ignition, I had to go into chemistry a little bit to figure out exactly what an oxidizer and options of those are. So like a flammable substance, for example, here on Earth, it's like wood, crumpled up newspaper. You need some kind of fuel to keep it.
Yeah, that's your fuel. So the flammable substance is the fuel. So your fuel
and that would be hydrogen on Jupiter.
Mm-hmm. Yeah. And the oxygen is there to really feed the fire, essentially. And what was it, Mike? A fancy fit, like exchanging the electrons to make sure.
I mean with hydrogen, so you'll have hydrogen and oxygen come together, and they form, They actually create water, but also release a shit ton of energy. And so that oxygen, you need that oxygen for to come together for the reaction to release all that energy, which is the fire. And then for your source of ignition, well, here on Earth, that would be, hey, I just struck a match. But you don't have big matches on Jupiter. But Jupiter does have lightning.
That's right. It does have lightning.
Epic lightning the size of the United States.
Yep.
As long as the U.S.
So basically, Jupiter has a fuel source. It has a source of ignition.
Yep.
However, it's missing a key component.
Missing that oxygen,
It's
everybody.
missing oxygen.
So
we have a problem.
Yeah, so hydrogen makes up 86.4% of the atmosphere of Jupiter. Helium makes up 13.6%. So basically, you're talking about 1% is everything else. That 1% is things like methane, ammonia, ethane, acetylene, carbon monoxide, ethylene, water. There's not a lot. So there's not really any free oxygen that's just kind of floating around in the atmosphere. And even if it was, there's not enough to make a big fire.
And so oxygen isn't the only oxidizer, but there's just so little of the other stuff on Jupiter that it just can't catch on fire at all.
Yeah, we would, if we wanted to light Jupiter on fire, or any of the gas giants, which they're all primarily made of hydrogen. Just Uranus and Neptune do have a higher concentration of methane, which is what makes them blue.
And ice giants as well. Technically, they're not gas giants. They're ice, because even though they're still mostly comprised of hydrogen, they have a lot of other stuff inside of them, more so than the other gas giants. So we just call them ice giants for funsies.
But, I mean, they do all have, all the stuff that, like, Mike just listed. Like, I specifically just noted these gases that were actually known to be pretty flammable. So your methane, ammonia, ethane, acetylene, carbon monoxide, that sort of thing. But, in all of these planets, you're looking at, like, parts per million, parts per billion, like, just such a small amount
it doesn't
of them.
have.
I was looking at Neptune, and ammonia is 600 parts per billion. That's like, how did we even find that in the first place? But that's nothing.
Science, technology.
Like when the dog farts in the room, it's way more than 600 parts per billion.
Definitely, especially if it's Leia.
Oh God!
Oh, man, that methane. Whew. Put Uranus to shame. So focusing on like hydrogen, since that is the main flammable gas that comprises most of the gas giants. So essentially, like for here on Earth, the flammability limit for hydrogen, it's based on a percentage of hydrogen.
I got a question. The flammability limit, I've not heard that term.
So there are flammability limits. All right, there's a lower flammability limit and upper flammability limits. I put in the notes here the lower flammability limit. So it's basically the lower flammability limit is like if your concentration is too lean, it won't catch on fire. But your upper flammability limits, if it's too rich, then it won't catch on fire.
Yeah, you got to be in that sweet spot.
So you got to be,
two.
you got to be in the sweet spot.
That anti-habitability zone.
So for hydrogen here on Earth, this is the lower flammability limit. It's basically with 1 atmospheric pressure. So
here on the surface.
Here on the surface of Earth, basically at sea level, so to speak, it's between 4% and 94%.
That's for oxygen.
That's
for oxygen.
Massive limit.
Right.
Nice.
So, and we have 20% of the atmosphere is oxygen. So, yeah, oxygen, if it's going to meet up with some hydrogen, it's going to react, and could create a little.
As long as you have a source of ignition.
That's true. Yep.
And fuel.
So the minimum energy here on Earth to light hydrogen on fire, the minimum energy for a spark of ignition at atmospheric pressure is about 0.02 millijoules.
Okay. And looking at calories, That's not even a Skittle.
It's not even a Skittle?
It's not even a Skittle.
Yes.
So it takes less than a Skittle to light hydrogen on fire.
In fact, if I remember right, it's about 2 to 3% of a Skittle.
I am
So it's a
so
little
glad
sliver.
we have. I'm so glad we have Skittles as a baseline
Me
because
too.
honestly, 0.02 millijoules. I have
Means
no
nothing.
idea what that means.
Means
but
I
but
looked this
less
up
than
and
one
it meant
Skittle.
nothing.
Less than a
Less than
Skittle.
one Skittle. I can visualize that.
And I think it's like for like hydrogen and oxygen, well, I don't know, you need like 2 parts hydrogen to 1 part oxygen.
Right. So
Yeah.
because the byproduct is water and H2O.
Oh.
So the byproduct is water
Mm-hmm.
and a shit ton of energy. And so all you gotta do is look at the Hindenburg. The Hindenburg was filled with hydrogen, and came in. There was a spark, and that little bit of a spark between the Hindenburg and that little spire, I guess, that it parked with. I don't know. Was enough for it to, explode, and the humanity and
The Hindenburg ultimate coming in hot.
Yeah.
yeah.
I'd
Yeah.
say so.
But it was a very slow coming in, and then it really became hot.
Humanity.
Yeah, and so and that was just a tiny little spark. And unfortunately, here on Earth, sometimes people will leave their gas stoves on, and it just takes
Yeah.
a tiny little
Right.
spark,
Less than a Skittle.
less than a Skittle. And I mean, sure, that is methane, but different. But it's still, it doesn't take much. And so with Jupiter, you have these massive lightning strikes. So the spark is there. It's just
Just
that
the
there's
oxygen.
you just need the oxygen.
So how much oxygen would need to pump in then? To
Oh, a
blow
shit
it
ton.
up? A shit ton? Okay.
shit
Is
ton.
that
Is
like
that our official,
That
our
is
official
an official astronomical amount.
shit ton
which,
of oxygen?
honestly, knowing astronomers, it wouldn't surprise me if they find some massive number and they go, what do we call it? The octagon? What? No, it's called a shit ton.
Yes, I like that. So, okay. So basically, if you're gonna go to Jupiter, don't bring a lot of oxygen.
Well, no, I mean you have to bump up the amount of oxygen basically to 4% of Jupiter's atmosphere.
Well, and then we're not
Yeah.
even taking into account Jupiter's atmospheric pressure. It does have 1 atm. It does. They register 1 atmospheric pressure at a certain layer in Jupiter.
Yeah, it's going to be up high.
Yeah.
It's going to be up pretty close. So, yeah, I mean, yeah, you're going to have to import a lot of oxygen. Kind of
4%
like
though, the mass. That's an incredible. That's a shit ton.
yeah. Basically, I mean, at that one atmospheric pressure level, you need at least 4% oxygen, and we're sitting at basically 0 right now.
Is Earth even 4% of the mass of Jupiter?
Yeah, would we need all of Earth's oxygen?
Oh, more than
Or
that.
more than all of Earth's oxygen?
Well, okay. You have 2 different questions in this. You said is Earth 4% of the mass of Jupiter?
Right.
Do you mean the atmosphere though?
Yeah, because Earth itself would be at least 4%. Yeah, so just the atmosphere then. That can't be right. So no, I'm going to say no. Earth's atmosphere is not 4% of the mass of Jupiter.
No.
And our atmosphere isn't all oxygen. It's oxygen and nitrogen and then some other
Yeah,
shit
and
in
so
there.
then it's 20% of 20% is oxygen, right? It's 20%, right?
Sure.
That sounds right. Let's call it 18.97.
We're not if anything, we are I don't know what I'm saying. We are always 100% accurate and factual on Cosmos with Cosmos. So
Down to the 1,000th decimal place, at least.
never take anything we say with a grain of salt.
I can tell you how much the Earth's atmosphere weighs. Now I can't compare this to Jupiter, but I can tell you it's a whole lot less.
Yeah.
The Earth's atmosphere is 5.148 times 10 to the 18 kilograms.
Okay.
Yeah, that is the mass of the Earth's atmosphere.
Can you do that in pounds?
42.
No. When you're at 10 to the 18th power, it doesn't matter what unit you put it in.
That's true.
Yeah, it's going to be roughly 5.148 times 10 to the 19 newtons, which is the metric equivalent of pounds. But and then you can double that, so roughly 1.5 times 10 to the 20 pounds,
which we in the science field call a shit ton.
A shit ton.
Shit ton. Yes, it is the official.
But that's still nothing compared to Jupiter's atmosphere. So you would need to pump in far more than Earth has to offer oxygen-wise to Jupiter.
Yep.
Far more.
Now, what about methane? Because obviously, as far as methane goes on Jupiter and Saturn, there's not a whole lot of methane there. But Uranus and Neptune Uranus has about 2.3% methane, and Neptune has 1 to 2% methane. And the lower flammability limit of methane is a lot less. It's about 4.4 to 16.4%. So we'd still need a shit ton of oxygen, but
you need a shit
would
ton
it
of
be
methane.
easier?
Just send all the
you
cows.
need more methane.
Yeah,
So we run into a
you need
problem.
double the methane.
Oh, wow.
Yeah, so for Uranus and Neptune, which have the higher methane, actually let's do Uranus because it's 2.3% methane.
Uranus would be filled with methane.
Yeah, it would be. That's Leia's home planet. Basically, you're going to need to double the amount of methane in Uranus's atmosphere. Also, you are going to need lightning.
Oh, they don't have do they?
Well, I don't know.
Do we know if Uranus and Neptune have lightning?
Wouldn't they?
Well, I mean, one would think. Except for
still...
Uranus. Uranus is really quite. If you look at it, it doesn't have a lot of storms. It doesn't mean that it doesn't have storms, because it does. Hubble's seen storms, but it doesn't have it to the extent that Jupiter has, that Saturn has, even Neptune. Neptune has more storms.
Neptune has had incredible storms.
And there's a little bit of a mystery around Uranus as to why it does not have the storms that Neptune has, because Uranus is closer to the sun, and so it receives more energy from the sun, so it should have some storms.
If only we could send more spacecrafts to Uranus and Neptune, except for the one that has ever flown by them, Voyager 2.
Yeah.
Well, I think there's one in the Decadal survey that would go out to Neptune and check out that planet on Triton, but that would still be, even if it gets greenlit today to begin to, plan out, make, launch, get there, it still won't be there until like 2038.
Yeah.
That's if they go right now.
Why does space have to be so big?
Otherwise, they call it like...
I think the question is, why do we have to worry about the military so much?
There we go.
Instead of putting more money into space. Because had we put more money into space, we probably would be parked right out there with Neptune right now.
Okay, now this is a rabbit hole. We can go
Yeah,
down this rabbit hole.
let's
But
save
I'm going
that
to bring
for
us
the
back.
hangover.
I'm going to bring us back a little bit here. So I'm going to go off script. I apologize.
Wait,
So this is
wait,
not
we
really
have a
bringing us
script?
back.
Oh, no, it's bringing us back to the question at hand.
Okay.
So if we did pump Jupiter full of the necessary oxygen to have it light on fire, here from Earth, because we kept our atmosphere, we didn't lend it away,
No.
what would that look like if Jupiter suddenly burst into flames?
Well, the cool thing, hydrogen burns basically colorless. Having said that, Jupiter does have a lot of other stuff in its atmosphere.
Yeah.
So there will be some. There would be some color. So, like if you see hydrogen burning blue, that's most likely because there's a little bit of sulfur mixed in it. So it's contaminated, quote unquote, with some sulfur, and so you get the color from that. But so hydrogen typically will burn colorless. So you're not going to see a lot of color.
So we won't actually see a great ball of fire.
No, but you would see something, because there is a lot of methane and ammonia and shit like that, and so it's going to contaminate it, so you'll see something. So it'll get really bright, but what's really cool is, first of all, Jupiter is not going to disappear, guys. You catch it on fire, it's not going to disappear. But what you're going to do is you're going to convert a lot of that hydrogen. You're going to mix it with oxygen, and you get water out of it. So you can get a lot of water a lot more water in the atmosphere.
Oh.
Because that's the byproduct, right?
Interesting.
Yeah. So here's something that just popped into my head. So depending on where this reaction occurs, let's say it's down in the a little bit into the cloud layers,
Mm-hmm.
Where there's some heat in there.
Yeah, so the reaction occurs.
Mm-hmm.
You have all this energy. Let's say it's spherical around the planet.
Mm-hmm.
It all happens at the same, radius.
Yeah.
Does it blow out all that other material? And so does Jupiter appear to get bigger? And then have, Jupiter. I'm sure Jupiter's great mass, will pull it back in. But does it go poof like that?
Like, I was thinking, like, would it gain some kind of Saturn-like ring as well if that were to occur? Because the force, if everything lived at once, for example, there'd be a lot of force into that. So maybe you'd extend that a little bit.
Yeah,
and
but we're
create some
talking
ring.
gas here, so...
Yeah, but it would freeze out there, and it'd just be a ring of ice.
Mm-hmm.
Yeah, possibly, yeah. I think that would be really cool. That would be really cool.
That'd be interesting. Jack says, would you get hot gas emission lines or would you get absorption bands from the burning of the lower atmosphere?
Kind of depends on where it happens, I guess.
Yeah.
If it's on the tops, you're going to get those emission lines.
Yeah.
But if
Now, for people listening and maybe they don't know, emission lines and absorption bands, exactly what are they, the difference and such?
they're lines.
So
They're
basically,
Bright lines and dark
Done.
lines.
yeah. So
So-
you're, you can go ahead.
All right, so emission lines is so if we look at the sun, and we get this spectrum from the sun, and I think Newton, was it Newton who was the first one who somebody around Newton did this.
Yes. I'm trying to, the two small pieces of glass
Yeah,
talks about.
I want to say Newton. Newton did
Planetary
this,
show.
but all right. So you get light from. Okay, all right. You're burning sulfur. So you have a Bunsen burner. Let's go back to chemistry class, guys. You have a Bunsen burner, and you're burning some sulfur. If you were to look at that light that comes from that sulfur. And you would see these, and make it into a spectrum, you would see these bright lines that come in at certain wavelengths. So, those are emission lines. Okay?
Yes.
So,
And each element has its own fingerprint of emission lines.
So astronomers, when they look out into the universe, they do like to look for neutral hydrogen, which is 21 centimeters. So if you ever hear about astronomers looking at light and the wavelength is 21 centimeters, which is really long, it's radio, I think, maybe microwave, that's hydrogen. And that's actually how they've kind of mapped out. They used these emission lines from neutral hydrogen to map out the spiral arms of the Milky Way galaxy. So, absorption lines is if you have a light source and that light's passing through a cloud, the material, the elements in that cloud absorb some of that light. So if you look at the spectrum, they absorb that light at certain frequencies of light, certain wavelengths. And so if you look at the spectrum, you'll get these little black lines in it. And so that's how you can tell what elements are in the cloud.
That was actually one of my favorite things in my astronomy class, in my astronomy lab that we did, was doing, we would look at emission and absorption lines, and you had these special like glasses that you would put on, and you would put like a tube of fluorescent gas.
Xenon, for example.
Yeah, or commonly, like in fluorescent tubes, they use neon and stuff. But you can get these tubes, and you can see the spectrum of it, and it was like the coolest, coolest thing.
It's kind of like finally getting an idea that, I know this isn't right, but like you think of our dimensions that we see, time and space around us, but then there's a whole other world that our eyes can't comprehend. So it's a whole other world that these instruments are picking up and that we can study. And to put those glasses on for the first time in high school or college or whenever you did, it just blows your mind. Like, these actually exist everywhere right now.
Yeah.
Yeah. So going back to Newton, I think what Newton did was, or somebody around Newton was,
It was Newton.
he projected the spectrum onto a wall and actually looked at it with a telescope. And so that's where you saw the black lines. And and absorption lines plus emission lines will equal a spectrum, a full spectrum.
Ooh,
And a rainbow is a continuous spectrum.
Yes, it is. Just indivisible light.
So now that we know, the question was, would you get hot gas emission lines or get absorption bands from the burning of the lower atmosphere?
It depends on where it happens. If it's if it's up at the very top, you're most likely going to get emission lines.
Otherwise.
But if it's down lower levels, yes, boom, the light goes out, but then it's absorbed by the outer bands of Jupiter's atmosphere, and so it's going to be absorption at that point.
Now, I really like the idea of just like picturing Jupiter on fire and like just you got flames burning away. Unfortunately, it would never look like that even if we could light it on fire, especially because we have to remember that space is a vacuum. So you can't have just continuous flames burning in the vacuum of space.
No, but you can have a continuous flame in the atmosphere of Jupiter. So, I mean, if all the fuel...
How would we see that?
Well, I mean, you can be on ISS and see forest fires here on Earth. So you would just need a powerful enough telescope to be able to see it.
Or a Juno.
Yeah, let's...
Yeah.
We need a spacecraft with spectrum glasses on it.
Yeah, Juno, go ahead, set Jupiter on fire, Juno.
Yeah.
Let's do this.
Juno has a little like flamethrower built in.
No, it's a fire.
Yeah, but to your point of space being a vacuum, though, yes, I mean, you couldn't take a lighter and and just out in space. All right, so you can't take a lighter. Lighter would have a fuel source going through, so it would keep a flame till the fuel source went away, but you couldn't catch the paper on fire that you're holding.
And then for people like me people who like to watch rocket launchers, you get these epic flames at the first stage here on Earth, and it gets higher and higher. But eventually it drops out. You see a second stage which ignites, and here on planet Earth we would see flames coming out. But all we see instead are the cones glow orange from the heat, and there's no flame coming out because you're in the vacuum of space. So that's another example in my mind.
Yeah.
That's super cool.
So whenever you see just flames in space in science fiction movies...
I love the Star Wars explosions. That's a drink. I love the Star Wars explosions and the Star Trek explosions and the pew 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 sounds, but god damn it, it's not realistic.
Well, no, I mean dramatics and realism, they clash sometimes, and so you can't have both.
But how cool did it look when Hodo there just zipped through that Star Killer?
Oh my god!
Ship.
That was the most beautiful scene.
Last Jedi.
Especially when they just cut all sound.
And they cut the audio, which is that they got that right, and it was beautiful.
It was glorious.
Yep.
So we cannot light Jupiter on fire unless we have a technical term, shit ton of oxygen.
Shit ton
which
of oxygen.
Is impossible. Oh, it's not impossible. So you can. There's nothing stopping from a gas giant getting that much oxygen. The problem is when you have these accretion disks as a solar system is forming, there's just not that much oxygen. So it's always going to be hydrogen, helium. So it's possible, but not really.
Yeah, even Earth's early atmosphere was predominantly hydrogen. It wasn't this oxygen-rich thing that we have now.
Even our oxygen here on Earth is still replenished with, our biosphere. So it's still a complex system we have. We just didn't get all this oxygen. We're also making it as well. So it's a complex system, folks. So we talked about what it would look like if Jupiter was on fire, if you could do that. I see in the notes here. What are some science fiction movies, for example, where you have a planet that's just always on fire, has an atmosphere on fire?
Well, I did a quick Google search, and I found one movie that is called "The Day the Earth Caught Fire."
Was this like a 50? It sounds like a 1950s
It was
movie.
it was 50s. I gotta relook it up again because I forgot to go back and actually look at it more.
Well, while you do that, I'll talk about my favorite movie with an atmosphere on fire, which
Okay.
isn't technically. So, Reign of Fire with Matthew McConaughey and Christian Bale. Let me tell you this. You can go up into the sky at any moment and a dragon will breathe fire upon you. The skies were lit with flames thanks to these ancient dragons coming from the crust of the earth to finally dominate their territories of the planet. So technically the atmosphere is on fire due to, oxygen lighting a match, things like that. They're dragons. I'm just killing time until Liz finds out about the day the Earth caught fire. And also you have Mustafar, which is a volcanic planet, but you have to imagine there's flames out there somewhere.
I mean, that's a Star Wars planet. Do we drink?
Yeah.
Okay. Oh, yeah. I love Rain of Fire.
It's a guilty pleasure.
Okay.
And the cast is surprisingly good.
It's a pretty good movie. So the day the Earth caught fire, apparently the atmosphere actually doesn't catch on fire. I guess, basically, there were a lot of weapon tests. Oh, 1961, by the way, 1961. And this movie, starred people, and essentially that the Earth's nutation, I don't know what that word is, has been altered by 11 degrees, affecting the climatic zones and changing the pole and the equator.
All
How do you
right,
change
makes
the
sense.
Pole and the equator, because
Well, I mean, if you tilt, that's true.
the increasing heat has caused water to evaporate and mists to cover Britain, and a solar eclipse occurs days ahead of schedule. I'm not sure how they sped up planetary mechanics. Oh, that was a Lord of the Rings reference right there. That little.
Oh,
So-
damn it.
Yeah.
For people who are watching, yeah.
I gotta get a drink, so.
And then they realize that the orbit of the Earth has been disrupted and the planet is spiraling in towards the sun.
Oh my god. Suspend all science belief in this one.
So, that's that. So the atmosphere actually doesn't catch fire and is irrelevant, consequently.
Can we go back to the Manhattan Project for a second? Let's go
Yes.
back in time to the Manhattan Project.
I know where you're going with this.
All right, so the Manhattan Project was started with a letter from one Albert Einstein. Albert Einstein did not participate in the Manhattan Project other than to convince President Roosevelt to actually do it. But
This is us building nukes, everybody.
yes, for building nukes, it's a project that built
Fascinating.
Fat
project.
Boy and Little Boy.
Fat Boy,
Little Man?
Little Man.
Yeah, which
sounds
exploded over Hiroshima and Nagasaki.
Immediately my brain goes Little John, but that is not correct.
So, the Manhattan Project, led by one Robert Oppenheimer, they built a bomb. They wanted to test the bomb.
Naturally.
Yeah, and they weren't sure what was going to happen when they tested it, and they literally thought that the atmosphere might catch fire. When it happened.
People were their part in the Manhattan Project was to do these equations to make sure that the atmosphere would not catch fire, and they were pretty sure it wasn't going to happen.
But you got to remember, you're introducing a fuel source. We already have a lot of oxygen, and there's going to be a spark.
Yeah.
Yeah, big spark. Big spark. So, so can you imagine though? You're sitting in New Mexico or wherever they did it. I think it was New Mexico. It was either New Mexico or Nevada.
There was Los Alamos.
Nevada. I think the first one was Nevada. I just know people, like actual regular citizens, would drive out to these sites to watch bombs explode in the 50s.
And then they all got cancer.
That's insane, and they all
Yeah.
got cancer.
Yeah, but the first time you blow it up, and
You don't know.
you just don't know. Like,
That's
okay, we
insane.
don't think the atmosphere is going to catch on fire, but there's a chance.
But the
There's
fact
a
that you
chance.
don't know
so
and you
let's
still do
test it anyway.
Yeah, we're going to do it anyway. So it'll put it into the war really fast.
That's the ultimate mad mutual assured destruction. Hey, you know what? We're gonna test this bomb, destroy you, but if it doesn't work, we all die anyway.
Yeah.
You mentioned Robert Oppenheimer. Every time I see the name Oppenheimer, that has just such a strong connotation now that I just see, his face with the bald head, kind of the old stressed out look, and he's kind of reciting what he thought about after he saw the first bomb explode during that test. And it's, that quote, "Now I am become death, destroyer of worlds."
Yes.
So every time I see Oppenheimer, even if it's just some person on the street, automatically I think that connotation. That's one of the stronger ones in my mind for names.
So then, clearly, without just a lot of help, we can't light the gas giants on fire. Can we light the Earth's atmosphere on fire?
Well, we tried with nuclear bombs.
I mean,
that didn't work.
we clearly it didn't happen with the nukes, but
You
is
would
it
need to inject a lot more. You would need to inject something like hydrogen, a lot more hydrogen. But hydrogen's so light, it just kind of floats up and goes away.
So it's like the reverse here on Earth then. Like, so with Jupiter, we got to inject a shit ton of oxygen, but here on Earth, we need to inject a shit ton of
Yeah,
hydrogen.
yeah,
Mm-hmm. Makes sense.
yeah. So I mean, the Earth doesn't have a lot of hydrogen in its atmosphere, and the hydrogen that it has is up at the very top because it just floats up. It's so light that it just floats up, and is not. There's hardly any down here on the surface. So the question is, where do you get hydrogen? Well, it's man-made. So the
You mean
same.
we can't mine hydrogen from like Jupiter or something and bring it back here?
Yeah, you could do that, but we're not. We're not right now.
No. So, for those of you on Twitch listening in, if you have a question in your mind that you want us to talk about, we'll gladly jump to that in the hangover. Because I feel now we're ready to go into some rabbit holes.
Yeah.
I think we at least have some questions here. So kind of in sum, no, you can't light Jupiter on fire. And if you wanted to, you need such an immense amount more of oxygen, more than the Earth has. It'd be like more than the weight of the atmosphere of Earth. If you can transfer that to oxygen, put it in Jupiter, still wouldn't be enough. So it's possible because oxygen exists in the universe, but it's not realistic at all to make that happen. Same thing with the Earth. We tried lighting our atmosphere on fire with nuclear bombs. That didn't work. Thank God.
We tried. A for
Damn it,
effort, everybody.
We tried hundreds of times with many different kinds of weapons. Still no go. So it's possible within the realms of the universe, but it's just not realistic at all. So the answer: can you light Jupiter on fire? No. It would take a lot of oxygen.
Shit ton.
Goodness
Shit ton.
gracious, no balls of fire.
Oh.
Actually, well done.
You know what?
Well
I'm gonna
done.
drink to that. That's a drink.
That's a good
So-
one.
Well, we'll drink it. All right, drink it.
And did you hear that? I had a dog bark.
You had
Oh.
a dog bark?
Well, drink again, everybody.
Drink again, dog bark. I didn't hear it, but let's do it because I like doing this graphic.
All right, folks on Twitch, stay tuned. We're gonna take, I assume, a quick break to pee.
Yeah,
do
we'll
the
be
hangover.
right back, and then
And
we'll go
let's-
into the hangover.
And those of you on the podcast, check us out on YouTube for the hangover because we're gonna talk about some weird stuff. I'm sure it's gonna be a lot of fun.
Okay,
So until next time.
let's hold on. Let's do a little audio pause and do a clean cut of just a sign off for the recording of the podcast, for my editing purposes.
Okay, well, tell me when I can talk.
You can talk now.
You can talk now.
Oh, okay. All right. Well, I was waiting from the
We'll
director.
say you now, Brandon. You could be like, "Thanks for joining us." Blah blah blah.
Thanks for joining us, everyone. We'll see y'all in 2 weeks when we talk about the topic of, this is a good question. It is a TBD. It's my favorite question,
My
TBD.
favorite. I love it.
So
I
yeah.
love it.
join us for TBD, folks.
Otherwise, thanks for joining us.
Cheers, everybody. Stay
See you in
safe.
a
Stay
bit.
healthy.
Safe.
All right, for those of you in YouTube land, not Twitch, Brandon, because we're
Oh,
using
damn
YouTube
it.
now.
Damn it! I'm behind the
Hey.
times.
But for your mom,
No, we'll talk about that in the Hangover
no. But I want more. What's going on with sun's?
with the sun and solar flares.
Yeah, I mean that's a very broad
Yes.
question.
Yeah, well, we'll talk about it. All right, we're going to be right back. We're going to regroup, and then we will see you guys in a little bit, in a couple minutes for the Hangover. So refresh those drinks and get ready.
Cheers.
back. Welcome to The Hangover.
The Hangover.
Hey.
Woo! Cosmos with Cosmos. And we got some exciting questions coming up here. We have my mother has asked what's going on with the sun and solar flares. Just, hey, what's going on with the sun and those solar flares?
Very broad.
And Jack
What's the
asked,
deal with these solar flares?
what's the deal? And Jack has a question triggering a drink warning, so get ready because it's coming up right now. Do you think it would be easier to build a Cloud City type structure in the atmosphere of Venus or Jupiter? Cloud City
I
Star
have
Wars
an
reference,
answer.
so we're just going to take a drink right now.
I was thinking hard about that for a while. I think I got an answer.
All right.
All right, but
Brandon
first,
with the answer.
but first, we're going to do my mom's question because she asked first. So we're going to talk about the sun and solar flares.
Okay.
I don't know if my mom would
What's
like
the
to
deal? I can't do if I could do a Seinfeld accent,
That's
I
a bit
would, but I
whiplash.
can't.
What's the deal with that's not, I can't. The sun and solar flares. So the sun is a big ball,
Burning mass,
it is a
burning
great ball of
hydrogen.
fire and plasma.
No.
It's
No,
plasma.
whoa, yo, hey,
No,
yo,
not fire.
yo.
It's not fire, it's plasma.
It is plasma.
But it's really, really hot, and it looks like it's on fire.
It does, like, especially when you look at it in
Like the
hydrogen.
like the hydrogen alpha,
Hydrogen
hydrogen
alpha line.
alpha.
Yeah.
Oh,
Oh, God, it's
so-
gorgeous.
I
God.
so badly want an H alpha telescope because I have my night telescope and now I want a daytime telescope, the H
Yeah.
alphas, and they look so beautiful.
Yeah, so when we were all at Arizona Science Center, I had...
Institution that shall not be named.
Okay, when we were all at the institution that shall not be named, I had looked into hydrogen alpha, and the powers that be saw the price tag and were like, nope.
What the fuck are they gonna spend it on? Sorry, that's another rabbit hole.
Anyway, I would recommend to anybody out there who isn't aware to Google like the close-up picture of the sun, or it's like it also is nicknamed like the sunflower sun image or whatever, and it shows like the convection
I
cells.
can't.
super
I
close,
can't believe
and
I
it's
got it. The current probe's really close to the sun. Oh, the one probe
Parker.
close to the sun.
Parker Solar Probe.
Parker, man, that has got some amazing pictures so far.
Did
Go
you
ahead,
see,
Mike.
Did you see the Parker picture of Venus? So Parker took a picture of Venus, and it is really super cool.
What?
Yeah. Yeah. So,
It's not the one I was talking about. But...
Oh, yeah.
all right. Well, you can't see it.
Yeah,
but,
you can't.
That's
So
fine.
Google that. I love whenever spacecraft launch and pass by planets for gravitational assist or what have you.
Mm-hmm.
They typically tend to like test their cameras on it, so you'll see these weird pictures of like Mars or Jupiter just based off gravitational assist when they're just testing the cameras, or like the Earth a lot of that as well.
Mm-hmm.
But it's just so cool seeing like Earth from this different angle we haven't seen before, and
yeah.
Mike has something.
just-
Mike has something to share with the class.
well, yeah. I mean, you won't be able to see it.
Okay, well, watch the recording of this episode on YouTube, and then you'll be able to see it.
Yeah, so what's really cool about the the Parker Solar Probe is it has this really badass looking picture of Venus, and it actually looks through the clouds. So you can actually see kind of the surface of Venus with it, and you see these little streaks in the picture.
I forgot I didn't put the new YouTube chat into our OBS,
Oh.
and that
And so
it was just our Twitch chat.
So you see these little streaks. Those are particles from the sun. Those are solar particles. That's the solar
Okay.
wind.
Oh, that's the solar wind. Okay,
That is the solar wind. If you can, oh, there it is. There it is. So that big blob is actually on the surface of Venus.
that hurts my eyes.
Okay, well,
And just Google Parker Solar Probe Venus, and you'll get the picture.
wow, that's cool. So basically, the sun is this huge, super hot ball of gas and plasma, and it has magnetic field lines that end up, they will get tangled.
Yeah.
So the
Like spaghetti noodles in the plates.
yeah, they get all tangled up, and what will happen is those magnetic field lines, then they get tangled up and they break, essentially. And so from that, you will get these solar flares, and you can get also really big ones called coronal mass ejections or CMEs.
Them's the scary ones.
And basically these are like I can't remember how many nuclear bombs, how many Hiroshimas
More
there
than we
are.
have here on Earth. More than we have
It's
on
a
Earth.
shit ton of Hiroshimas that are erupting at once off the basically surface of the sun, and that can pose a problem to us here on Earth. Luckily, we have a magnetic field. We have a lot of stuff protecting us. But in the past, these CMEs if they've heading in our direction, they have actually affected our satellites. There was a blackout in Canada that was caused because of a coronal mass ejection.
And it's still very possible for a big enough one to hit our satellites and knock out our communications. It's still extraordinarily possible.
And when I was at Clemson, there was actually a significant part of the physics department that was their sole project. The thing that they were interested in was figuring out a way to protect our satellites from CMEs and from all of that kind of stuff.
Yeah.
So,
Luckily, go ahead.
One of the best ways to protect the satellites is we can have enough advanced warning, kind of. I forget how long it takes for the particles from when we see it to hit the Earth, but we have enough advanced warning if they have advanced, technologies and satellites to position it on the opposite side of the Earth when it occurs. But most satellites don't have the capability.
Yeah. Now, and luckily we do know that because the sun, its magnetic field, it rotates and it actually flips, the poles flip, and so it ends up unwinding. So it's a 29-year period, basically.
Right, it's 11? I thought it was 11
Well,
years.
it's 11 years and
for
then...
the sunspots.
Between the minimax,
Between minimax. So you get solar minimum and solar maximum. And so when we know when we're in a solar minimum or when we're heading into a solar maximum. And generally, although there has been times when we should be seeing more activity on the sun and we're not. But when we're heading into solar maximum, that's when those magnetic field lines are really getting super tangled. And then when the poles flip, then they unwind, essentially.
And I do also want to point out that solar minimums and maximums have nothing to do with Earth's climates.
No.
That's it.
No.
That said, Maunder's minimum
Okay.
in the 1700s, there was an absence of sunspots, and
there was a cooling period.
There was a cooling period during that time as well.
Was that the mini ice age? The quote unquote
Yeah,
mini
there was
ice
like a
age?
little ice age, yeah.
But keep in mind, you're talking about a long period of time here.
Yeah.
So it's not like it was, over the course of just like 1 year or something like that.
Yeah.
But another thing too, you bring up solar flares and the breaking of magnetic lines for it and that type of stuff. But before those lines break, you'll actually have plasma that follows the lines. Prominences. And look up prominences because there are some amazing pictures of prominences on the sun. It's just beautiful. And what's really cool is during a total solar eclipse, if there is a big prominence, you can see it. You can see it.
So, because we're in the hangover, my first memories of CMEs and prominences and activity on the solar surface comes from Star Fox 64. Because there was a level you can fly above their star, and you would actually see CMEs come above you, and you had to dodge them. But it was my first knowledge, the first memory to know that, these things are extending off of the sun and coming down, which is really cool. And that was before I knew, what the hell was going on with the sun.
Well, my favorite solar flare is from Star Trek: The Next Generation, and it was Klingon made. It wasn't even a real solar flare. They wear the Klingon bird of prey. This was during the the Civil War between Worf's family and the Duras family, and so Worf's brother is being chased by some Duras people, and he goes right over the surface of the sun, and then he does warp speed, and it creates this Klingon-made solar flare.
Or does he do Worf speed?
Clever. There was another episode I watched recently where the Enterprise... I think there was some kind of time issue, of course, with flipping between timelines, where they had to travel really close to a star and heat up the surface of the Enterprise because the ship behind it couldn't take it. This is when Beverly Crushed tried to take command because Picard was somewhere else.
Oh, this is vaguely familiar.
Yeah, and they had to go super close to the sun and base this experimental technology to burn up the ship behind them. Anyway, that's
your
not
mom
related to
remembers
series.
it, and
Of course she does.
of course she
I need
does.
to make like a nerd alert button. Anyway.
So
Nerd alert would be the whole episode.
And I realize this, we rarely mention it, but we don't have a rule about Star Trek references.
No, this is why.
But we rarely mention it.
We reference Star Trek way more than we do the other ones.
But that's because we know it's safe.
Probably.
That's probably true.
I would like to point out, Jack's, the unwinding is like, the unwinding of the magnetic field of the sun's magnetic field lines. The unwinding is like the sun is going through a Silk's dance routine.
Oh.
Yeah.
Yeah.
It unwinds and then winds back up again, and then flips and then unwinds and winds back up again.
So why does it get all wound up? It's because of that differential rotation.
Differential rotation, yeah. It rotates faster at the poles than it does along the equator. And that we can see that in Jupiter, the gas giants as well. Jupiter, Saturn, Uranus, and Neptune, they have differential rotations.
That's probably a good reason why you look at Jupiter. Well, yeah, you have that spot, the different speeds, and also different directions as well based off winds. But just, the water painting arts of Jupiter, so much thanks to that twisting of the gas.
Yeah. Now, you don't have differential rotation on Earth. Earth is a solid body. It's not a gaseous body or plasma body. So
there's a solid surface that we can stand on, not deep within
No. The solid surface is a trick the government's playing on you. Don't believe your eyes.
It's always
Birds
a trick.
aren't real.
Jack asked, what was the one with the Ferengi shields? The Star Trek
Ferengi
episode
shields.
with Ferengi
the Frankie
shields?
shields.
Was that TNG? That wasn't Next Generation, was it? That sounds like a
Deep Space Nine.
Yeah.
Frankie shields.
You know what? I don't know.
Your mom might know.
Fun fact.
Sure.
I've forgotten who, the main Ferengi in Deep Space Nine. What's his name?
Quark?
Yeah. So he's in one of the first episodes of Next Generation. Remember when the Ferengis are like this primitive culture, and they're like, they want the female of Next Generation? He's one of them. Yeah, he's one of them.
Well, I remember watching
actor is one of
DS9, and then they had Quark, and I was like, oh, he's from Next Gen.
Probably.
So anyway, I said that was Brandon's episode, the one with the Ferengi shields.
The one. Okay.
Okay, so
Oh, you're right. That's right. Because they brought all these different species together, and there's a whole brouhaha about who killed who and the Ferengi shields. Yeah, gotcha.
He knows. He got you, Jack. So clearly, we need an episode talking about the sun, because the sun is super cool, but not cool, literally.
And then we also did an episode talking about Star Trek. We have a Star Trek episode.
We do have a Star Trek episode. Check that out with Shannon Branson from Shannon Barnston from Geek
about
Show
a year ago.
podcast. Yeah.
Woman, listen to us.
But we have another question to talk about in The Hangover, which is, do you think it would be easier to build a cloud city type structure in the atmosphere of Venus or Jupiter? I mean, I would say Jupiter because there's more atmosphere to fucking float in.
Yeah. That'd be my
and more
thought.
hydrogen,
But
which is
there's-
lighter.
But first of all, Venus is much closer to Earth, so much easier to get supplies there, back and forth, and has much less radiation around Venus, so as less hazard to get through.
Well,
yeah.
Well, it's 90% carbon dioxide atmosphere.
hold on.
No. So they're okay. I'm just talking about like getting to the planet in general.
All right.
Juno is so radiation hardened. It's a super radiation tank.
Look, if we can build a cloud city in a planet, clearly length of time for traveling between planets is no longer an issue.
Wait a minute.
True.
Does Venus have a magnetic field?
Oh.
I'd assume.
Well, because
if it doesn't, you're going to be bombarded by.
I don't think so anymore. Because
You're getting those
Venus,
cosmic rays.
Venus doesn't have much volcanic activity happening anymore,
Well,
does it?
Well, no, actually it does, but that doesn't
So-
necessarily mean.
But I mean, it would if it's roughly the same size as the Earth, so you would think it would still have somewhat of a convecting core.
Oh shit! Venus is known not to have a magnetic field. The reason for its absence is not at all clear.
Yeah, its
Oh,
core has got to be
shit.
smaller than the Earth's because the Earth's core, its size goes back to the creation of the moon
Yeah.
and the impact with that Mars-sized object.
But so besides the radiation, which I still think is a major issue for Jupiter, besides that issue, I don't know about the atmosphere of Jupiter and if there's an Earth-like layer, but there is an Earth-like layer in Venus at a certain X amount of
Well,
miles.
there is where you can have one atmospheric pressure.
Pressure, but can you go out there and survive?
Well, that's why you stay
Well-
in Cloud City.
Here's the thing: is that one atmospheric pressure is really high up because at the surface of Venus is 90 times that of the Earth's atmosphere.
Yeah.
So its pressure is 90 times that. So 1 ATM is way high up. It's gonna be high up, but it might be far enough within the atmosphere of Venus to where it's reasonably protected.
But Venus is also
And-
really hot.
It is
Well, no,
hot.
but at that level of the atmosphere, I recall reading this off of 1,000 different science fiction novels, and they all scientifically prove it. So I'm going with my gut here.
Okay.
At that level, not only is the proper amount of atmosphere and a bit of livable area, but the heat is acceptable up in that atmosphere as well, because it's just like the Earth, the higher you get, the cooler you get. So same thing with Venus, higher the cooler.
Yeah, but if Venus is roughly the same size as
this
the Earth.
and this one atmosphere, well, just based off the gases around you, be high enough to have that temperature as well.
All right, so one atmosphere is 50 kilometers above the surface, which is about 35 miles. 30 miles, we'll say, and it is 20 degrees Celsius, so roughly about 75 degrees
Yeah, see?
At Venus?
on Venus. Yeah, at that height,
Point Venus.
Okay.
according to the Google.
I just feel like with Jupiter, you have more room to play with where your Cloud City's at and how much, you know.
Well, Google confirms my own personal beliefs, so I'm gonna go with that.
All right. Since when did you? Anyway, I was gonna make a political comment.
So how about this? I would much rather live on a Jupiter cloud city just off the view alone.
Mm-hmm.
Because
Yeah.
what view does Venus have? A big sun, and that's it. There's no cool stuff. Jupiter, you got all those moons and the views, the auroras. I'm sure would extend down to where the hell you're at.
As Jack said much earlier in the main episode, that Jupiter is like the fashionista planet.
Oh, absolutely. Well, you got Saturn.
No, but look at... Okay, I'm sorry, but compare pictures of Jupiter to Saturn, and because Jupiter's atmosphere is way more dynamic and colorful. Yes, it has the rings. It has the rings,
Which
but Jupiter has
matters.
rings too. It's just they're
Yeah, I
thinner.
can't
It's just a
see
thin
it.
ring. It just depends on, your ring preference.
God loves Saturn so much, put a ring on. That's all I know.
All right, we have another question.
Oh.
Do gas giants have a gravitational pull? And the easy, simple answer to this is yes, because everything that has mass has gravity.
Yeah,
In
so,
fact, no, can I do my spiel? I want to do my spiel.
Do your
go
spiel.
ahead. Jeez.
I'm doing my spiel. In fact, okay, you have your own gravitational pull. Everybody has their own gravitational pull, but we're not as big as gas giants or planets, so we don't really feel that gravitational pull
Now,
between ourselves and these smaller objects.
now, Liz, I have a mass and you have a mass. I am currently around 900 miles away from you. Is my gravitational mass interacting with your gravitational mass from 800 miles away?
Yes.
But we can't feel it at all because it's so fucking minute. Because it's
Are you telling
nothing.
me? Are you telling me then, if it has a mass, it interacts with something? So this is some kind of force that connects all of us together between me, the rock, the tree, You.
Oh, we gotta take a drink.
Force exists, everybody. The force is real.
And the force is gravity.
And the force is gravity.
Force is gravity. Thanks, Newton.
But yes, Mom, the gas giants do have a gravitational pull, and because they're so much more massive, they have a huge gravitational pull. So, for example, like, you know, whatever you weigh here on Earth, you're going to weigh, what, 16 times that on Jupiter?
16 times that?
Yeah.
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 And it depends where at as well within Jupiter.
So if you're looking for, if anybody's dieting, don't go to Jupiter.
Go to Pluto.
Go to Pluto. Yeah, go to Pluto.
That's where you want to go.
Yeah.
Yeah, so anything with mass has gravity.
Mm-hmm.
Yeah, and we get that question a lot in the planetarium. So the moon has no gravity. Actually, it does. It's just it's 1/6 the Earth's gravity.
You would jump 6 times
there's-
as high?
6 times higher.
Yeah.
There's also a formula I remember learning in high school that you can figure out exactly how much mass is between these two objects, how much gravity they have, and how much they're interacting.
Yes.
What's that formula, Brandon?
There was a line involved, and like, was it the G1 minus G2?
Is there a squiggly
All right,
line at
so
all?
it is Newton's. It's Newton's equation of gravity, right? You have universal gravitation.
Yeah.
So it is big G, which is called a gravitational constant, of the mass of object 1 and the mass of object 2 divided by the distance between them squared.
This is why we
kinda
have
had that.
fancy physics man.
I kind of had that. Wait. So let's just say me and Liz both weigh 80 pounds. And we're 900
Holy
miles.
shit! What?
I don't know. I didn't want to be. We both weigh
Look,
183 pounds.
I am 115 pounds.
Okay. All right. So Brandon goes from, let's say we both weigh 80 pounds to, let's say we both weigh 183 pounds. All right. Why don't, okay.
Welcome to the Hangover.
Okay. What is your question?
So we're able to figure out the force of our gravities from our distance away, given the mass we have.
You can, based on your mass, figure out how much
So
of
I
a
was
force
to
you
have-
guys are
But
giving
we-
each other.
physics
we have
can't do that.
wait. We have to clarify. Mass does not equal weight.
Nope. No,
True.
it does not.
Weight does not equal mass, which is people
Right.
a lot of times think they're the same, but they're not.
So I have 7 mass.
Your weight
Well,
is
I
how
think-
much.
No, I think we need to. You're going there. I think we need to
Yes.
talk about what mass and weight are.
Yeah,
So mass is an intrinsic thing.
it's how much matter you're made of.
Yeah. So
basically.
how many atoms that you have
Yeah.
basically in your body and all that kind of stuff. So
Yes.
weight is it depends on where you are.
Yeah.
So your weight on Earth is different from your weight on the moon. However, your mass on Earth is you will have the same mass on Earth as you do on the
'Cause
moon,
you're
as
made
you
of
do
the
on
same
Jupiter.
amount of matter. It doesn't
Yeah.
change.
Yes, unless you lose a shit ton of
Yeah.
weight between going to the Earth and the moon. And so mass is intrinsic to you. Weight is intrinsic to the planet.
If you lose an arm, you've lost some matter.
Yeah, you've lost some matter. I would not go to that extreme to lose some weight, but
No.
right now I might consider it.
Brandon's apparently figuring out things.
It's mass equals weight divided by the acceleration of gravity. Okay.
Yeah.
But
So
that-
weight.
So that weight is then in newtons? No, that's what we get.
All right.
We have the kilograms then?
is okay. Hold on. Weight is going to be in newtons if you're in the metric system. Pounds if you are in the. What are you doing?
I'm fucking shit up. Is
lost
what
you.
I'm doing.
We
What?
lost you.
Yeah, I know. I accidentally deleted our camera. It's fine.
What?
We just had a
Okay.
black hole sun.
You
We're
have
fine.
to leave things alone. All right, so mass is kilograms for the metric, and to be honest, I don't remember what it is for the imperial system, the American system,
Merc.
because we never fucking used it in class.
No.
It was always metric.
Metric is science. You don't deal with bullshit imperial.
Yeah, so whatever it is, but yeah. So kilograms for
To be fair, even a kilogram itself is a really strange weight. Like the official definition of it,
It's not a weight.
it's incredible.
It's
No,
a mass.
Sorry,
We're all
so
about
the-
science on this show.
1,000
But there-
grams.
There's an official definition of
Yes,
a
there
kilogram.
is. Yeah.
And it's changed. It's quote unquote changed, but it changed just the definition of the weight, but the mass. Then the mass stayed the same. Actually, what I want to do is look it up and read it because I remember it being insane.
Yeah, so it's in Paris because the French came up with the metric system, and so in Paris they have a standard,
God,
this object which is, they say this is 1 kilogram and it defines kilogram. The problem is that's a very man-made thing, and so like in length, they're like this meter stick is. And eventually what they decided to do was try to get away from that man-made thing. And like for length, it is it's based on the speed of light. And so that defines how long a meter is. And so it becomes more of a universal thing.
Okay.
It's funny, though, how they define it so that it equals, the length of that meter stick. But
and we have the definition is 626,070,015 times 10 to the negative 34 kilograms. Meters squared S negative 1, whatever the S is.
that's seconds.
Oh, seconds? Okay. Yeah, it's in terms of Planck constant.
Oh, okay. All right. So they're making it universal. So they're getting away from this,
Of course.
from this massive object in Paris and making it more universal.
Okay.
And I love the idea. It's like the idea of the foot at one. This is, I'm sure, a myth. The foot is equal to whatever king's foot size is at the time in Paris.
I would not doubt it.
I would.
But-
That
fucking doubt
sounds
it.
totally plausible.
Yeah.
But this
Yeah.
ball in Paris is kept in like this vacuum chamber surrounded by guards that defines our measurement systems around the world. So yeah, it's better
Except
to
in
have an
America.
actual
Except for
definition of
America, which we go, hey, how about an inch being the length of your thumb, half of your thumb?
Hey
But
guys.
But I will say, because miles per hour and Fahrenheit, at least Fahrenheit, there's more intervals within Fahrenheit. So I can think of 75 and know exactly what it is. But when I think of 27 degrees Celsius and
Wow.
25 degrees Celsius,
Well, yeah, I mean, Fahrenheit has a little bit of a, gradation to it.
continuum. Yeah, great. That's a good word.
Yeah, but Celsius is at 0 degrees, water freezes.
Makes
At
complete
100
sense.
degrees, it evaporates.
Oh, that
It
makes
boils.
sense.
Yeah.
Yeah.
So that's how you get it.
Oh.
Fresh water freezes at 0.
Yep.
I have no spatial awareness, so none of this means anything to me. Jack on YouTube says Imperial made it easy: pound mass and pound force. Pound of force.
Okay.
Horses, though, are measured
God.
by a
Oh,
man's
God.
hand. So, like, you have like
Is that for your mom?
Yeah. So, like, a horse would be like
really quick,
16 hands.
really quick. I think it was a week ago or something like that. Liz texted me at some. This is what we do. She texted me at some point in time. She goes, "How much do you think 1 horsepower is actually equal to?" And I'm like, "What the?" I assumed it was 1 horse, but I
We
guess
both
not.
assumed
We
that
both
1
assumed
horse
that.
equals 1 horsepower, but 1
But-
horse equals 15 horsepower.
It involves a pulley system and a certain weight at the end. So 1 horse can lift up 15 horsepower because it can lift up this amount of weight based off a pulley system. But it blew my mind. I assumed it was 1 fucking horse.
Yeah, no, it was yeah, that so my mom says, so Tam, which is one of our horses, one of my mom's horses, is 15 hands from the withers. What are the withers again, Mom?
Also, you can say Tam, T-A-M?
T-A-M, Tam.
So that's a great character in the book series called Wheel of Time, which is coming out on Amazon Prime hopefully this year. So get ready for Tam, motherfuckers.
That's not who Tam is named after. In fact, Tam has a longer name. It's Tam O'Shantner, something. I don't know. That's...
All right. So for everybody, let me tell you the 2 questions that we asked last night.
last night's questions?
Yeah, these are just last night's questions.
Uh-oh.
Was this to me?
Yeah.
Oh god.
So, all right. So,
Welcome
here's
back.
question number one. Is there time at the North Pole?
Oh god. That's right.
Okay, so we were watching this comedy special, and he was talking about time zones, and then referenced the North Pole. Like, what do you do at the North Pole? You just walk around, and you're in a different time zone. And then I went, holy shit, is there time in the North Pole?
Yeah. So that was question number one. Question number two is, how powerful would a volcanic eruption have to be for a rock
That's
to
right.
reach escape
Which
velocity?
was a neat question. They're
That
both
actually is a really good question.
they're both really neat questions actually. They're both neat questions, but just
So-
the way they were presented, and I was busy at the time, so it caught me off guard.
Yeah, so the answer to the first one is there is time at the North Pole,
Mm-hmm.
and if you're standing at the North Pole, it is whatever
Whatever
time zone
you
is
want it to
convenient
be.
for
It's
you.
whatever time you fucking want it to be.
So it's
Yeah.
T equals me.
Yeah, pretty much, because the North Pole is not habitable, and so explorers can use whatever time zone that they
Yes.
choose.
But there is some kind of, is it like a flag or a monument or a pedestal up
Oh
there?
yeah, they're
yeah, there's something up there that people leave.
yeah,
but-
so you can probably ring around it. But here's that question part B is, if you're at the North Pole, where's north? There is no north. Everything is south.
Everything is south.
Everything is south from you.
One
There's
second.
There's-
Wait.
there's no
wait,
east.
Wait.
If you're standing
I-
at the North Pole, there's no
Wait.
east and west, only south.
Wait, let everyone else catch up because I haven't thought about this. If you're at the North Pole, if you're standing on that fucking pedestal, everything is south. But then is it like south, southeast,
Nope.
east,
Nope.
east?
There's no
It's
east.
just-
There's no west. There's no north. There's just south.
Okay, so you're there, and let's say, for example, you stay there for 2 days, for example, and it's like a blizzard or some shit like that.
On the pedestal.
You're on the pedestal, and 2 days is meaningless because there's no fucking time up there apparently. How do you know which way to go to get back?
You just start walking, and then
And just hope for
Yeah,
the best.
because if you're at the North Pole, Polaris,
What does
the
a-
North
what
Star,
does a compass
in this
look
currently,
What does a compass look like at the
can't-
North Pole?
You're at magnetic
Well,
north is
wait,
different
magnetic north-
than the
damn
North
it.
Pole. Magnetic
Damn it.
north is
Okay,
off of
so,
the North Pole.
So different question. You're at magnetic North Pole, and you can't just say it can't, because obviously the fucking compass is going to do something.
well, yeah,
So
it's
what
going
does
to
it
point
do?
to the magnetic north,
just
which
spin
is
around?
not Earth's rotational north.
So does it just try to point down?
Yeah, it's going to point south of you. So
I guess just
the compass is going to be really confused.
walk somewhere.
You know what's really weird? This is really
Ow.
actually kind of cool to think about. Is if you're standing at the North Pole, really and truly, you are. Oh man, what are you? So if you're standing at
You're
the
a
North
human,
Pole,
my human.
if you're standing at the North Pole and you're facing wherever the magnetic pole is at that time, because it does move, everybody.
It's in Russia
Just
right
You
like
now.
are-
Polaris moves.
You're above. Are you above both the North and South Pole? No, I guess the compass will face to the north, but it also will face. It'll actually will show you where the magnetic North Pole is. Yeah, okay.
So basically, if you're at the North Pole or the South Pole,
You're in a-
things get
you're in a
real
weird-
fucked up.
You're in a weird physics place.
And in the South Pole, you don't even have a South Pole star
No.
to
no, you
help
don't.
you, even though it's useless. Basically, it would be useless. But
Okay.
All right. Well, here's the second question.
Okay.
Shit.
the second question is, how does Santa know when it's Christmas if there's
Oh,
no
this wasn't
time?
This wasn't the question.
No. The actual second question was how
What-
powerful.
Wait, no, I need to answer Liz's question. So here's what happens with Santa.
Oh, okay.
So as we all know, Santa has many elves in his workshop to
Yeah.
make the toys. Through the last couple of decades, they've gone from wooden toys to these more complex electronic toys, for
Like
example, the
Xbox
PS5s.
Yeah.
A lot of the PS5s, sure, they may be manufactured a lot in Korea, but they're also manufactured in the North Pole, little known fact. So they've accompanied these technologies actually to create their own space program to launch GPS satellites just above the North Pole and the South as well, and the equator so they can triangulate and figure out what's what. And so they use space technology to figure out the exact date according to the Gregorian calendar, which I subscribe to. So that's how they tell space technologies with elves.
Welcome to our world,
you.
everybody. And let's be honest, it's about ready to get a lot crazier here in the future.
Oh,
The Hangover,
boy.
Cosmos to Cosmos.
The Hangover is just going to be...
Yeah, hold on to your butts in the future,
hold
guys.
on to your butts.
Hold on to your butt.
Yeah. The second question is, how powerful would a volcanic eruption have to be for a rock to reach escape velocity?
Which is a really cool question. So typically when I think of, rocks reaching escape velocity, that's started on Earth. There's some an asteroid impact, for example. A really big one, like in Chicxulub crater, the one that wiped the dinosaurs. Lots of objects reach escape velocity during that impact.
Yeah, but that's an impact.
Right, that's an impact, an external force hitting the Earth. This is an internal force exploding from the inside.
Inside out,
so
yeah.
that force has to be so much more. Mike, you have an answer.
I do, because I looked it up. So what I did was I looked up the largest volcanic eruption on Earth, and I got
In
the
recorded
Tambora.
history.
Yeah, it's recorded history, but I got the Tambora eruption, which was 100 some odd years ago, and the velocity, and I would say that this eruption most likely is probably pretty fair for any of the other big eruptions in history.
Okay.
The largest volcanic eruption had velocities, ejecta coming out of 650 meters per second. So what is that in American? It is 1,454 miles per hour. Okay, to actually escape the Earth, you need to be going 25,000 miles an hour. So it is well short. Well short.
Okay.
So basically, I'm gonna guess. I'm gonna put out a hypothesis. A hypothesis that for volcanic ejecta to reach escape velocity, the Earth would have to be destroyed.
Like many
The
Yellowstones
Earth
going on.
would have to blow itself up, basically.
It
Are
would
you
be
saying
an
we
Erupt
extinction event.
itself up.
It would be an
Are you
extinction
saying
event.
we need an external force to emit a laser beam deep inside the core to heat up and then explode the planets in some kind of Death Star scenario?
Star Killer base.
Yes. Yes, drink to that. But also, one of the things I wanted to say here, which is obviously why I'm saying it, we talked about it reaching escape velocity, but one of the more famous eruptions is probably Krakatoa in the 1880s. And my favorite fact about this Krakatoa eruption is that it was so loud that, first of all, it could be heard from 3,000 miles away. And also, the sound waves actually reverberated, was it 3 or 4 times around the Earth? So, seismographs here in the U.S. picked it up. Is how intense it was. It picked it up from all over the world. It reverberated 4 different times around the planet.
And that was a volcano.
Eruption.
That was a volcano. I want to go back in time just a few years.
A few years?
Just to Valentine's Day.
Oh, here we go.
Yes.
Say it right, though. Say it right.
I can't say it right, so I'm going to say it the way I want. Chelyabinsk. It doesn't matter. It's Russia.
I was yelled at for this. Chelyabinsk.
Vodka Chelyabinsk.
Russia with this vodka.
We had the asteroid in Chelyabinsk, Russia.
So,
What do we know about Russia? Chelyabinsk and vodka. Next question.
Pretty much, and Putin and
and
And also,
where
Russia
were-
has a fascinating
where were
history
all
of
the trees
revolution.
laid down?
Siberia, Tunguska.
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 All right, so
Fascinating history, Russia, by the way.
let's just go back a few years. And the Chelyabinsk
Was that
asteroid.
2012?
I want to say it's
2013?
2012, 2013.
Nearly 10
2014?
years ago.
Oh, wow. Oh, wow.
No.
So,
Still.
that volcano just erupting massively is heard around the Earth, ringing the
Wait,
bell
what are you
3
talking about?
times. Okay,
Krakatoa. Okay.
Krakatoa, heard around the
Okay.
world 3 times. This It's not even 60 feet across. This asteroid that is 60 feet across explodes over Siberia, Russia. Its shockwave also is heard 3 or 4 times around the world, and it's much smaller than that volcano.
So it's between one of the largest explosions in recorded history and a tiny asteroid boy.
Yes. Yeah. Imagine. Yeah, a little asteroid whisper was heard 3 or 4 times.
Space forces are greater than internal Earth forces.
So imagine if that asteroid was twice the size. Maybe 10 times the size.
120 feet across?
120 feet across. And imagine, just say if it was a mile, the crater that it would form 10 miles across. A good rule of thumb is to say that the size of the asteroid, multiply it by 10. That's how big its crater is. It's not always true, but just rule of thumb. So the asteroid that exploded over, that hit northern Arizona. Meteor crater.
I just passed by it 2 days ago.
1/10 of a mile. That's all it was. That created this massive hole in the ground.
Which is a mile long. Is it a mile diameter?
It's a mile in diameter.
Yeah.
It's the universe is actively trying to kill us.
Mm-hmm. Which also, if you ever had a chance to see a meteor crater, like I love the Grand Canyon is awe-inspiring and magical, and definitely worth seeing.
Just don't fall.
Meteor, that was made over millions of years, but meteor crater are made in a fraction of a second.
Fraction of a second. And can you imagine being in Flagstaff, Arizona, seeing this, was it 50,000 years ago that this occurred?
Flash of light.
If you're in Flagstaff, are you getting fucked over by this impact?
Oh, you're going to get fucked over. I don't think you're going to get killed.
Okay.
You're not going to get vaporized, but you're going to get fucked over in some kind of way. Yeah, can you imagine seeing that site? Because Meteor Crater is maybe an hour.
What was the planetarium show we made that discussed these impacts?
Oh God, what was the name of that show?
Attack of the Killer Space Rocks.
Attack of the Killer Space Rocks. We got to make it 1950s, right?
Anyway, I think this is a good episode. Topic to do in the future is like what
I was just thinking, I want like one episode dedicated to Tunguska. I would love that.
Just Tunguska?
There are eyewitness accounts of Tunguska, and there are people wrote down in diaries.
The guy got knocked off his rocking chair.
He did, and was thrown off in the house.
Okay, everybody, in 2 weeks we'll be talking about Tunguska.
Maybe not in 2 weeks, but at some point.
We'll see.
Okay, so
give me some research.
So, I mean, there is clearly evidence of asteroid impacts on planets that have caused basically meteorites to land on other planets like Mars and impacts on Mars causing meteorites to land here on Earth. But for like an internal planetary event to cause ejecta to release escape velocity, I mean, you would basically need a huge hole in the Earth to occur, a huge explosion within the Earth.
Yeah,
that creates a massive hole.
So Krakatoa,
the
biggest pimple pop of all time.
Yeah. Oh, wow. Dr. Pimple Popper Extreme.
Yeah. Wow, that got gross. But yeah, what an episode that would be.
The lava flows of pus.
Yeah. So basically, you have the largest explosion on Earth from a volcano. Multiply that by 12. And that's what you need to have something leave Earth to go elsewhere. The moon, Mars, wherever.
Is there at any point in Earth's history where it would have had that ability internally? I mean, I would think now it's cooled down enough where it wouldn't. But maybe in the early solar system formation, and you have a lot of...
It's so difficult because 12 times the largest known eruption is an incredible amount of energy.
Oh, it is so much energy. But
I don't think so.
Maybe the early Earth history, but it would need to be preceded by maybe like an asteroid impact to provide that energy to kind of mix stuff up and.
So maybe late bombardment period.
Yeah, if that, but
Yeah, it seems pretty. I mean, the most volcanically active object in the solar system is Jupiter's moon Io, which has how many volcanoes? Over
about 400
400
Over
volcanoes.
400.
And
no
we've
volcanoes.
actually-
active volcanoes.
And NASA has actually observed 80 volcanoes erupting at once on Io, which
And
is
you can see it. Just go Google it, guys. You can see it in
amazing.
GIF form.
yeah. Google Prometheus
Yeah.
of Io. The letter
Prometheus.
I. And
What
the letter
a
O.
good name.
You know, like here on Earth, we're like, hey, you know, that volcano in Hawaii is going off, Kilauea. And then you might get like another volcano that goes off, and like, oh, we got 2 volcanoes. No, this little tiny moon of Jupiter, 400 active volcanoes. Not only that, Io, the reason why it's so volcanically active is because it's being
We didn't say that.
warped by Jupiter's atmosphere. So
Gravity, yeah.
yeah, so
it's being squished. It's being pulled and squished by
pulled
Jupiter.
and
Like-
squished.
Like
let
an
me-
accordion.
But let me tell you how high the tidal pulls and squishes are.
How high?
80 feet.
80 feet.
80
Oh
feet.
my god.
That's huge.
So you would go up and down
80 feet.
And this is a small moon, folks. It's not like the Earth. It's a small moon.
And that's why it is so volcanically active. It's because it has it's feeling such incredible tidal forces from Jupiter.
Because Jupiter has a lot of fucking gravity.
It's got a lot of hydrogen. A lot of hydrogen.
Guess it.
But no flames. No flames.
All right. So I'm trying to think of one last good question for this hangover. Fire, volcanoes, asteroids, moons, tides. All right, we getting anything here? Let's spit shot this together, guys.
You seemed like you were on a roll with all
Yeah,
that.
I didn't realize there was going to be a question.
Normally I have questions ready because I like asking the stupid questions and handing it off.
I would like us to coin this term now. My mom has just suggested it on chat. Volcanic fart.
That's awesome.
Oh, look at that.
Vol-
Oh, now I can see all the chats we just had.
So a volcanic eruption is no longer a volcanic eruption.
It's just a
It
volcanic
is a
fart.
volcanic, just like explosive fart.
It feels like a planetary fart.
A planetary fart.
That sounds right.
Like the Earth's feeling a little gassy. It's got to release some of that.
But some of them are Leia farts.
Just a sulfurous smell.
Oh God, yeah. Where y'all die.
Yeah.
How big of a dog would you need to fart and reach escape velocity?
How big of a dog? It is Leia. So the size of Leia.
You know, I'm rethinking my career choices right now. So y'all have fun.
I mean, I gotta say, a pretty cool profession is a volcanologist.
Oh yeah.
Oh.
Well, unless you had something to say, Liz.
Oh no, Jack just said. Jack says pyroclastic fart, which I really
That's
like.
good too.
I like that.
So we had talked about being a
But is that
volcanologist.
really a fart? That's not a fart. That's a blowout.
Oh, that's a toot.
Oh, that is.
You got a different kind of ejecta.
Oh, I have to go change clothes.
That's the flow.
None of that eject is reaching escape velocity. Though.
Yeah, that's not a fart.
So, you mentioned volcanologists and geologists being a really cool job. It made me think of the one individual, I forget who it was, who was helming a station near Washington Mount, the one that blew its top, like in the 80s.
Mount St. Helens.
Mount St. Helens, yeah. This one guy that was manning the station at Mount St. Helens, he saw it go off, and in his diary, he wrote down everything that was happening and covered all the instruments so that they would be safe. But no, he knew he was going to die because this was coming straight. It was coming right at him.
Yeah.
So he wrote down in his journal everything that was happening. He covered all the instruments so that they would survive, but he knew he was going to die while doing this.
And he had to do that quickly. He had to do it quickly.
So the amount of, I guess we can just say perseverance and want
Ingenuity?
Ingenuity. Yeah, I guess, yeah, actually. To see death staring at you, but still completing your job because you knew people can learn from it. Those are the people I love. I know there are many others like that, but he's one of the people that literally saw death coming at him and said, "Nope, I'm gonna do my job and science the shit out of this."
Yeah, well, you might as well because you can't outrun it.
Yeah. And then,
Oh,
so
yeah.
you have that, where he
also,
is.
by the way, Google that because it's an amazing story. And
Yeah, so
amazing.
you have that story, but then you also have the dude who's like, I ain't leaving my house. And then,
My cabin, yeah, the guy who didn't leave his cabin.
yeah, and then so he died. So it is this a story of, you know, we have to quickly write down everything about this. That story, and also the story of stupidity.
And like
Well,
you
one's
could
a
actually
Republican and one's not.
God, sorry. I just love it that you can actually see on this volcano mountain. You could see it expanding from the pressure inside of it. It was visible. Holy shit, that's amazing.
You know, but when you look at like these volcanic eruptions where you see the pyroclastic flow, it doesn't look. It just looks like smoke and ash. Like you don't realize like the temperatures involved
And
and
the
like
power.
how the power and how it will absolutely annihilate you. It just
Yeah,
looks
because
like
you're looking at it
it's just
from a
a
distance.
cloud.
Let's just
Yeah.
be honest. You're looking
It's
at it
just
from
a
a
dark
distance.
cloud.
So it doesn't. It's always from a distance. So it doesn't have. It has this majestic beauty to it,
Yeah.
and you don't realize the violence that it
Yeah.
has.
That's one of the things like we as people have difficulties understanding is the power that objects actually have. A car going 10 miles an hour is an insane amount of energy, but like a volcano going off is unfathomable. The amount of energy it has inside of it.
Yeah. You know, it's like it makes me think of looking at pictures of the shadows left behind from Hiroshima and Nagasaki.
Yeah.
Like you can't you see like, oh, that was a person, but you can't comprehend how that was a person and how
Right.
that
It's just
you
Yeah.
just see the mushroom cloud and whatnot, and you
No,
can't realize the force and the heat
Okay,
that is behind it.
But for those we hear shadows and like so when the bombs went off, the shadows of people were burned into the ground. They were the ghost of Hiroshima. You could actually see where they were standing at the time it went off. The heat and light was so intense. One of my favorite books, which I hate to have to be written, but is John Hersey, Hiroshima. It follows 4 individuals who are at the sites of Nagasaki and Hiroshima and documented it to this journalist and wrote these stories down. And just the vivid details that the power of these. So we talked about Robert Oppenheimer earlier, and he talked about I become death, destroyer of worlds. I don't use that lightly. Honestly, this is the reason why I quit one of my jobs, is because the power that these weapons have, unfathomable and terrifying. No one should ever be given that power. And when you can burn shadows into the cement based off an explosion miles away, no, that's too much.
Yeah, it's a very. Oh, I'm sorry. Go ahead.
No, you go. No, I'm gonna say something glib. You go.
All right. It's a sad statement on humanity that we will put so much effort and resources and brain power in trying to figure out how to kill one another with these insane weapons instead of figuring out how do we feed everybody, how do we educate everybody, how do we keep people from getting sick.
Just the amount of money that was put into the Manhattan Project dwarfs any project Lewis has done.
And, let's just be honest. The amount of money today put into the Pentagon, and we have come full circle because I mentioned this in the main episode. The amount of money put into the Pentagon, just cut that in fucking half. Let's just cut it in half and put those resources into medicine. Just letting people go to school.
And if we did that, we'd still have the biggest military on the planet.
Yeah. Our military, I forget what it was. It was like if you take the next 10 countries
Oh, yeah.
and
Stack them together.
add up their military budgets, we're still like Well, I don't know.
Okay.
Sometimes
Way
better.
on military
So-
stuff.
I mean, greater.
Liz, you had the glib statement. I have a glib statement as well, so you go
Okay,
first.
my glib statement is, meanwhile, the sun says, hold my beer.
Oh, nicely done. Okay.
Oh, you can't have back now.
No, it's not beer.
My glib statement goes back to Simpsons, and the Simpsons did it. So there was, I think, it was a Treehouse of Horror episode or something with Codus and Kane, and they were taking over the planets. And this is when Homer Simpson says, "Don't blame me. I voted for Kodos because Kane was destroying the planet, whatever." But it turns out that these aliens in these giant tube helmets and tentacle arms were driven off by Moe and other people when they got a board and put a nail through it, and he ran them away with his board and nail. And hey, people got it. But at the end, when Kodos and Kane are flying off out of don't worry, I'm coming home. When Kodos and Kane have left the Earth, they say to each other, "Don't worry. One day the humans will build a board with a nail so big they will destroy themselves." But it's also very true.
Yeah,
Yeah.
we're totally going to destroy ourselves.
Oh, yeah. Yeah.
Well,
With great power comes great responsibility,
Which we don't have.
exercise at all.
All right, Uncle Ben. Do we have? So we're an hour into the hangover. Do you have any last thoughts here?
Basically, we can't light any of the gas giants on fire with the current resources and technology that we have.
It's always tomorrow, though.
The sun has tremendous explosive power and energy. Side note, we should utilize that some way. And volcanic eruptions aren't going to be so big that they ejector reaches escape velocity.
Planetary farts, please.
And the
Planetary pyroclastic farts.
And the North Pole is
And the
time,
North
is a
Pole
warp.
has no
Physics warp.
fucking time or direction but south.
Unless you have the North Pole elves that can geostationary our satellites and anyway.
Yeah, the elves. Never, but Brandon, never trust an elf.
God damn it. That's a drink, folks. I can't believe a pointy ears is outscoring me.
What were we doing the other night where we're like, never trust an elf?
Last night?
Was it last night?
Yeah.
Never trust an elf.
I can't remember.
I don't remember either. Never trust an elf.
I don't know.
Yeah, all right, well.
On that note.
You guys have a real glimpse into our lives
Oh boy.
with our questions and all that kind of stuff. So, welcome.
Well, with that, everyone, thank you for joining us, Cosmos with Cosmos, both the main episode and the hangover, which I love the hangover because there's no pressure. We just go for it and
So
see what
bullshit.
happens.
We just talk.
Drunken bullshit.
So we'll see you next week, maybe for
No,
Tunguska.
2
2
weeks.
weeks.
In
2
2
weeks.
weeks.
Maybe for Tunguska, maybe for something else.
We'll find
Who
out.
knows? I don't know. Live long and prosper. Stay safe. Absolutely. Wear a mask.
Yes,
And
socially distance. And cheers,
Socially
everybody.
distance.
Cheers. We'll see ya.
cheers.
Thanks for
See you
hanging
then.
out, everybody. I'm gonna do a quick little just goodbye to everybody watching us on YouTube. Thanks for hanging out as always.
You
It
too.
was good to see everybody out. I know we're so used to Twitch now.
I know.
Let us know. I know it took a bit for my mom to get chat on YouTube, but let us know if YouTube seems to be working out for you. We'll probably do at least next few episodes with YouTube just to see how it rolls and whatnot. I know Leia's going.
Okay, yeah,
Crazy.
just keep going.
Okay. Anyway, all right. Bye, guys.